The first task is creating and testing 6 Ethernet cables. You'll need male Ethernet cable, RJ45 connectors, a crimping tool, and a cable tester. Start by cutting 6 pieces of cable to appropriate lengths. For each cable, carefully stripe about 2 inches of the outer jacket to expose the 8 individual wires inside. Untwist the pairs and arrange them according to the T568A wiring standard. The pinout from left to right should be green white stripe, solid green, orange white stripe, solid blue, blue white stripe, solid orange, brown white stripe, and solid brown. And the other end according to the T568B wiring standard. The pinout from left to right should be orange white stripe, solid orange, green white stripe, solid blue, blue white stripe, solid green, brown white stripe, and solid brown. Make sure the wires are perfectly flat and in the correct order. Then trim them to equal length. Insert the wires fully into the RJ45 connector, ensuring each wire reaches the end of the connector and aligns with the correct pin. Use the crimping tool to firmly crimp the connector onto the cable. Repeat this process for the other cables. Once all cables are created, testing them is crucial. We have a wire tracker, also known as tone generator and probe. It consists of 2 parts, an emitter and a receiver. This device is mainly used to trace and identify cables, especially when many cables are bundled together or hidden inside walls. To use it, one end of the network cable is connected to the emitter and the device is set to scan mode. The receiver is then moved near different cables and the correct cable will produce a beeping sound when detected. It can also be used to test cables by connecting both ends of the cable to the emitter and receiver and switching to test mode. If the LED lights from 1 to 8 glow in order, the cable is properly connected. If any number is missing, swapped, or lights up together with another, it indicates a break, wrong wiring, or short circuit. The second device is a network and coaxial cable tester. It is used to test different types of cables such as RJ45, RJ11, USB, and coaxial cables. To test a LAN cable, one end of the cable is connected to the main unit and the other end is to the remote unit. When the tester is turned on, the LED indicators numbered 1 to 8 light up in sequence if the cable is correctly wired. If a number does not light up, it means the wire is broken. If the numbers light up in the wrong order, it indicates incorrect crimping or crossed wires. For coaxial cables, the tester can also show whether there is a short circuit, proper termination, or no connection. In simple terms, the wire tracker is mainly used to locate and trace cables, while the network cable tester is used to check whether the internal wiring of the cable is correct and functioning properly. Let's labeling all 6 computers. This might seem like a minor detail, but in professional networking environments, proper documentation and labeling is essential for troubleshooting and maintenance. Now it's time to establish the physical network topology. Place the network switch in a location where all 6 team members can easily access it. The switch should be plugged into a power outlet and turned on. Each person will now connect their computer to the switch using one of the tested Ethernet cables. Once all 6 cables are connected, verify that the link lights on the switch are green or blinking green for each port. These lights indicate an active connection. If any connection shows problems, check the cable is properly inserted at the both ends and that the cable passed the earlier testing. Now we move to the configuring IP addresses on each computer. The network we are using is 10, 20, 30, 48 with the subnet mask of 255.255.255.240. This gives us usable IP addresses from 10, 20, 30, 49 through 10, 20, 30, 62. Each person will configure a static IP address on their machine. Each person must ping all 5 other computers to verify bidirectional connectivity. Ping is a network diagnostic tool that sends ICMP echo request packets to a destination and waits for a reply, confirming that the network path is working and the destination is reachable. At the conclusion of this ping test, you have verified that all 30 possible connections in your network are functioning correctly. This comprehensive testing demonstrates that your physical network setup, cabling, switch configuration, and IP addressing are all working perfectly.